How does that one?
That went in really well.
Hey, welcome back. I'm Chris Chase with the Western Flyer Foundation. And in this episode, I want to take a look back over the last few weeks. All the great work that's been done on the boat. The bilge stringers are now installed. Most of the ceiling structure has been installed, or what the inner planking some people call it. And most of the deck beam structure has been installed. And I want to take a deep dive into the anatomy of a wood boat deck. You know, what's a beam shelf and a shear clamp? What's a king beam compared to a regular deck beam? Let's just take a look at all the parts and pieces that make up the structure of an old wood boat deck. The fore and aft structure in the Western Flyer is built up using a combination of different sized timbers. The shear clamp and beam shelf, which runs the entire length of the deck edge and helps hold up the ends of the deck beams, is built up using a 3 by 12 inch timber. The 6 runs of 3 by 7 Douglas fir make up the bilge stringers, and they also run the entire length of the boat. And the Western Flyer has an inner hull planking, or what we call the ceiling planking. It's made up using a full dimension 2 inch by 4 inch yellow cedar. In a Northwest fish boat, the vintage of the Western Flyer, it wouldn't be that uncommon to find original hull planking 30, 40, or even 50 feet long. But when it comes to the inner hull structure, we need to build it up using shorter timbers, 20s and 24-foot timbers. To join the timbers together, we use a series of nib scarfs. The bilge stringers absorb a lot of energy as the boat moves forward through the seaway. So we end up using a nib scarf instead of a glued feather scarf. This gives us that nice solid stop built into that nib. And over time, we're not just relying on bolts and glue to hold the two pieces of wood together and keep them from sliding across each other. We have that nice solid stop. The lower 4 courses of the bilge stringer, particularly in the stern, went in with little trouble, but the upper 2 courses all the way along would need to be steamed to take the fight out of them, allowing them to twist and bend into place. Not every piece of wood that'll go into the boat is painstakingly patterned and cut to shape. Often when working with some of the longer fore and aft timbers, like the hull planking, the bilge stringers, or the ceiling, we'll edge set it into position. This is a process of using clamps, wedges, or a porter power to push the timber to the desired curve. It'll often pull back a little bit from the desired location. You'll have to pound it in position, maybe kerf the joint a few times, hit it a few more times until it sits exactly where you want. And then you can fasten it off to each individual frame. As the last few bilge stringers got installed, it was now time to mill up the Alaskan yellow cedar we had cut and stickered from last spring. The ceiling plank was originally 2 inches thick and made up of random width Douglas fir boards. We've opted to use yellow cedar, 2 inches by 4 inches, with one fit shutter plank to close up the gap. Most of the main deck beams were installed almost a year ago. In fact, the shear clamp and the aft beam shelf were two of the very first pieces of wood put into the boat. They make up that L-shaped timber that runs the entire length of the deck structure. The main reason the house was removed last February was to allow better access to the decking and deck beams below. Once the house was out of the way and the decking had been pulled up, the deck structure, including the beam shelf, could be evaluated for needed repairs. It was pretty evident right off that the beam shelf from the back of the stem all the way to the back of the brake beam would need to be replaced on both port and starboard. We opted to use a piece of 4-inch thick, 16-quarter by 28-inch wide, almost 40-foot long piece of Sipo African mahogany. Pete was able to nest each component of the beam shelf, both sides, into that single timber. He cut them out and he connected them together using an anchor scarf. The Makita Power Planer makes short work of the shaping process. And I bet if you could go back in history and ask a shipwright what tool he would want more than anything else, I bet the Power Planer would be near the top of the list. But also maybe a drill motor. Once the beam shelf had been lowered into place and bolted permanently to the top of each frame head, the deck beam structure could start to be assembled. The deck on an old fish boat like the Flyer is made up of using a couple of different kinds of beams. We have the king beams, which are the front of the house, the back of the house, and frame out the fish hole hatches. And they're made out of 10x10s with a camber cut to the top. And then you have the regular deck beams cut from 6x9s with camber on the top. And then you have Carlin beams running fore and aft, kind of like headers in a window in your house. And the last beam is the break beam. It's that timber that steps the deck up from the aft working deck onto the foredeck. It's almost a 26-inch step, and it breaks that shear line. And as long as that Hey, thanks for taking the time to watch the video. But before I end this episode, I thought I'd try to answer one of the most common questions I get, either in the comments box or emails or in person. And it's, what's the deal with the red lead paint, or the orange paint, I guess they say. And it's exactly what I just said. It's red lead paint. It's red lead suspended in linseed oil with turpentine thinner. And we use it for a lot of different things in the boatyard. It's kind of an industry standard historically. It's a little hard to get these days, but we still use a lot of it. We use it for a vapor barrier, we use it for corrosion resistance on metal, and we use it probably the most commonly as kind of a toxic layer between two pieces of wood. So if some teredo worms get into one board, like the bug shoe, it doesn't immediately transfer up into keel. Or if some rot gets going in a frame, it doesn't immediately want to transfer to the frame next to it. It's that toxic layer. There's a lot of other paints kind of like it. They're actually orange, and they call them red lead replacement paints. And they're actually a vapor barrier paint, but they don't have that toxic layer of the lead. And the lead really gets it done. We get this paint from George Kirby and Company. I don't know if you can see the can, in New Bedford, Mass. Anyway, thanks a lot for watching the video. I sure enjoy making these videos, and I just really enjoy sharing the project with everybody. Thanks again.